So example number 2, we talk about number lines. And so with a number line, you may be familiar with putting numbers on a number line. And when we look at the number line that's given in this example, and this example once again is going to highlight learning target 1.1b. So example number 2, learning target 1.1b is what we're highlighting. And we have a number line that is given to us at the bottom. And just to discuss briefly a number line as maybe a refresher, if we were to, in general, divide it in half and put a 0 in the middle, numbers moving in this direction would be our negative numbers. Numbers moving to the right would be our positive numbers. And this is our set of all real numbers. And so if I were to put numbers in general, our integers, because we got both positive and negative, if we were to add the integers to this, we would say 1, 2, 3, 4, 5. And in this direction, we would have negative 1, negative 2, negative 3, negative 4, and negative 5. So we have our integers. So that leaves the question of where would our rational and irrational numbers fall? Well, look, once again, they are decimals, and the distinction between them is whether or not they are terminating or repeating. And if they're terminating and repeating, they will be rational numbers. And if they do not terminate and do not repeat, they will be irrational numbers. And so if we were to place those types of numbers on the number line, they would fall between our integers, somewhere in between. And whether they repeat or terminate will determine if they are classified as rational or irrational. So those are the numbers that are going to fall between our integers on this number line. And so when we look at the numbers given, let's read our example. Our example says Coach DeBoard collected data on the number of home runs hit by players on the BCHS softball team. His results showed the following numbers of home runs hit by each player during the season. Plot the data on the number line. Well, a couple things we have to notice. First, when we look at the numbers, what types of numbers in general, if we were to classify them, what do we have? Well, pretty much looks like our natural numbers. We don't have zeros, so we're not going to consider it a whole number. We don't have negative numbers, so we wouldn't necessarily say integers, but natural numbers do fall in every single one of those sets. But if we were to look at the most basic set that we could call this, we would call this our natural numbers. And we have to place these somewhere on the given number line. Now, what I tend to do is I tend to look at the smallest number because I've got to label this number line. So I look at the smallest and the largest number given in the data set. Well, my smallest number is a 1 and my largest number is a 9. So on my number line that is given, I need to be able to have a smallest value of 1. And again, when we look at the numbers on a number line, moving to the left, the numbers get smaller, and moving to the right, the numbers get larger. So my smallest number, it would make sense to put over here on the left. So number 1. And then the easiest method is to just fill in the numbers from there, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And notice that 9 is also included on my number line. So I have accounted for the entire range of data that's given. And so to plot these values, what I will do is I will take a dot for each number and I will place it above the corresponding space on the number line. So let's begin with this number 7. Well, notice that I marked it out because I don't want to forget a number. That is one of the most common mistakes that I see, is that we overlook or forget to include a number from a large data set. It's not as hard on this data set because there's only 1, 2, 3, 4, 5, 6, 7, 8 numbers. But as we get larger and larger sets of data, it's easy to forget one of the numbers in the data set. So as I place the dot above the corresponding spot on the number line, I'm going to mark it out in my data set to make sure I don't forget any. So there's 7. 4, place a dot above the 4. 6, so I'm going to place a dot above the 6. And notice here that we have a 7 repeated. We have this 7 that is repeated again. So what this says is that 2 people on the team, 2 players on the Boyle County High School softball team, had 7 home runs. And so we don't ignore that fact. I want to be able to look at this number line and easily tell that there were 2 different players that hit 7 home runs. So what I'm going to do is I'm going to put a second dot above the 7. Now, I would encourage you to make sure that you make sure there is space between the 2 dots. And don't put the 2 dots, for example, right on top of each other where we can't tell what the data is telling us. We want to make sure that we can easily and quickly look at this number line and tell how many players correspond to each one of the numbers on the number line. So there's my 7 that I've placed on there. So let's 6 and 7. Now there's the 9. So dot above the 9. 2. Our 1. And once again, we have another repeated number. So in this case, we'll put a second dot above the 2. And I'm going to go back and double check to make sure that I have accounted for all my numbers. So if I go back and count, I have 1, 2, 3, 4, 5, 6, 7, 8 numbers in the data set. I should have 8 dots on the number line. Please, whenever you are plotting data on a number line, go back and double check to make sure you have all the dots. So I have 1, 2, 3, 4, 5, 6, 7, 8 dots. So I've accounted for all my data. I can easily see how the data is laid out on the number line, and I have accounted for and included the entire range of values on my number line. It's also neatly organized, and I can easily and quickly evaluate and analyze the data.